Okay, my friendly friends. We went over area and perimeter in the last video, and our geometric eye in the last video. But I skipped the circle example, and in the worksheet that you did, there was no circles, right? And that's because I wanted to dedicate a separate video for it, because that one's a little bit more complicated than what the other shapes that you're used to. So let's say there's a circle right here. There are 4 things you need to know about the circle. You need to know what the R stands for, what the D stands for, what C stands for, and what that little symbol means. Let me make it a little better, actually. Boom, boom. So, in a circle, the beauty about the circle is if you had a measurement, let's say you had a nail. Let's say you had a nail. Boom, boom. That doesn't look like a nail. A nail. You put it on the table, boom, 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 and you attach a little string to that nail. And however long that string is, let's say it's just 6 inches, right? And then on the other side, you put a pencil or a pen, whatever it is, right? Boom. And you get that pencil, and you try to go forward with it to whatever length the string is. That is what makes a circle. The beauty about the circle is that one length you get from the center to the end of your pencil or whatever it is, that length of 6 inches is going to be the same around. If we look at a circle, if we were to get a center point here and we were to make a line from here to there, again, let's say, for example, 6 inches, it's going to be the same there. That's what makes a perfect circle, right? Just think of the clock. Nice little normal clock. The big hand, the little hand, it's the same measurement. It's just moving directions all throughout, right? That's important to note because that half length measurement, that little line from the center to wherever that one edge of the circle is, that is the R, specifically called the radius. All right, that is what the radius is. It's the half length from the center of the circle to the one end of the circle, which is the same throughout. You could be given it like this, you could be given it on that direction, on this direction. It doesn't matter. It's always going to be the same. The diameter, that's what D stands for. Diameter, it's pretty straightforward. It's just the double of the radius, aka it's the full length of the circle. So in this specific circle, what would be the diameter? If I made a separate line here from one end all the way to the opposite end, that would obviously be 12 inches. All it is double the radius. So if you have the radius and they ask for the diameter, you should know what it is. It's just doubling whatever the radius is. If they do it vice versa, if they gave you the diameter and they asked for the radius, it's up to you to know, oh, the radius is half of the diameter. So if they gave you 12, you know the radius is 6. C is circumference. Circumference, all right, which is just a fancy way of saying, let's go to our formula sheet, perimeter. This is why circumference of a circle is under the perimeter section. Remember I told you don't have to worry about these ones because the perimeter is just adding up all the outside sides of your circle, of your two-dimensional figure. Well, the thing is, the circle does not have a side. It's a weird shape, right? It's like an endless cycle. Measurement has a curve to it. It's not like boom, boom, boom. There's no direct lines. There is no edges. So that is why they can't call it a perimeter. That's why they had to give it a fancy name. They called it the circumference. But it's up to you to know that circumference just means perimeter of the circle. It just means the outside measurement of your circle. And we're going to go over how to find that today because obviously with all the other shapes, to find the perimeter, all you have to do is add all your outsides. Well, there is no sides to add here, right? It's a circle. There's no sides. So how do you find the perimeter? How do you find the circumference of a circle? Using the formula that's given on the formula sheets. but we'll go over that in a second. This symbol is extremely important. From this point forward, you must substitute that symbol whenever you see it with 3.14, my friends. It is the number for pi. That is right. This symbol is the pi symbol. It is such an important symbol. It has its own special day on the calendar. It is 3.14. It is March 14th. That's Pi Day. I expect on March 14th for y'all to send me a message saying Happy Pi Day, right? And then send me a pie if possible. So now that we learned all the key elements to a circle, let's figure out how to find the area and perimeter, or sorry, my bad, not perimeter, circumference of a circle. So let's use a different example here. Let's say I gave you a circle like this, and it was some stupid word problem saying this is the top of a swimming pool. This is a swimming pool, right? And you want to know how much water to fill the pool with. What are they asking for there? Hopefully you saw the video before this one. It's obviously asking for the area of a circle, right? To fill in the pool means area inside. So we must find the area of this pool. So let's say they asked that, and they had given a picture of the pool, which is right here, an aerial shot of it, right? And I don't know, they'll give you some water picture here with some little water marks. But then on the bottom here, they give you this. 14. What is that measurement representing? Did they give you the diameter or did they give you the radius here? Well, it's up to you to know that they gave you the diameter, okay? And that's going to be important. They don't have to always put it in the middle so nicely for you. They don't always have to give you the radius. They don't have to always put it there. They could give it to you in different ways. They could even trick you even really, really bad by giving you the pool and then not even giving you the radius or diameter of the pool. They could give you they could say that you want to put the pool right next to your house, right? So this is your house right here, an aerial shot of it. There's your rooftop, and your house measures, let's say, 20 feet by 10 feet, let's say. And they say something along the word problem. They say the house is half the length of the circle of your pool, I should say. It's up to you to know and say, wait, the house measures 20 feet that way, and it's half of the length of the circle. I know from here to this half length of the circle should be 20. Ooh, I found my radius, right? That's how they're going to trick you on the GED. Just be prepared of it. They're not always going to just give you a nice little mark on your circle and saying diameter is given or radius is given. No. Just be aware of that, okay? But anyways, they give us this right here. So we're given the diameter of 14. Let's go find the area because that's what they want to know. What do you do to find the area of any shape that's including the circle? Is locate its formula. So in this case, circle's right there. It's right there. A equals pi r squared. What did I tell you to do last time in the last video? Always write out the formula by hand, pi r squared, because it helps. Substitute everything with parentheses if you can. Put in the information. We know pi is always going to be 3.14. What's the radius for this circle that's given? Is it 14, you? Do I put 14? No, they gave you the diameter. So this is the other way they try to trick you with circles. They give you the diameter knowing full well that the formula requires the radius. So they expect you to just put 14. They expect to fool you. Are you a fool? Are you going to fall for their tricks? No, you aren't. You know you need to find the radius of the circle, which is easy. It's half of the diameter, which in this case, half of 14 is 7. Now that you've filled this in, what are you going to do, my friends? You're going to do this by hand? You're going to take out a scratchy sweeper and try to do it by hand? No, you're going to take out your calculator and just let the calculator do the hard part for you. 3.14 parentheses 7. The squared should be on the outside of the parentheses. Boom. A equals, what was the number? 153.86. Or let me do it down here. 153.86. You just found the area of this circle using your newly found techniques of knowing what the radius, diameter, and pi was. Okay? Now let's move on to find the circumference, aka the perimeter. Let's say they had given you the exact same circle and they said, by the way, after finding how much water you could fill in the circle with, you got to buy a railing, a curved railing to go around the pool. Well, around means perimeter, in this case circumference, so you must find the circumference here. How do you find the circumference? You go look for the formula sheet, because that is how you're going to find the circumference, is through the formula, because we can't just add any sides because there is no sides. And when we come here, we enter a dilemma. I see some weird thing. C equals 2 pi r or C equals pi d. There happens to be two, boom, boom. There happens to be two formulas here. Don't think any fancy of this OR. That's literally saying or. It's either this formula or this formula, okay? So now, why do they give us two? Just for convenient purposes. They say you can use the C equals 2 pi r formula, or you could use the C equals pi d. So I'm going to write them both here just so I could show you what's the purpose of giving you both of those examples. C equals 2 pi r or C equals pi d. Do you kind of guess what's going on here? They gave us two options. Either one you use, you're going to get the correct answer. It's just convenience. If they gave you a circle and they had given you the diameter like they did in this case, if you wanted to use this formula, you'd have to split the diameter to find your radius, right? Which is what's needed because they gave us the r there, which you can do. You could do C equals 2, 3.14, oopsie, and then the radius of 7, and then put that in the calculator, and you'll get your correct answer. Or you could use this formula, which is C equals 3.14, and then the D, which is the 14, which is what they gave us. They're both the same thing, except if you use this one, you got to make sure you split your diameter, right? Or you could use the formula that already includes the diameter in it. They just give you two options, that's all, right? You decide whether you want to just stick with one always and just always be aware whether you have to split or you don't, whether they gave you the radius or not. But yeah, if you see that they gave you the diameter, you might as well just use this formula. If they gave you another circle and they give it to you like this, 6, you might as well just use this formula because you know they already give you the radius. There's no need to double the radius to try to come up with the diameter. None of that. You'll just probably use that one, right? So yeah, in the example before, the diameter was 14, right? So which one am I going to use? I'll probably use that one there to dump into the calculator. I'm going to do, oopsie, 3.14 parentheses and then 14, easy peasy. Is just a quick little multiplication. 43.96 is my circumference. 43.96 is my circumference. I need 43.96 feet of railing to go around the perimeter of the pool. Pretty cool, huh? This is everything you need to know about the circle, my friends. Please go into the worksheet and do all the different circles that there are, and the different formats that they are in, and just refer to the formula sheet and just memorize your little cheat sheet here of your different keys that'll help you with this circle.